Okay, sorry to Ryan Nelson. If you're watching, Ryan, we did half the lesson and didn't record for you. So, but it was review. It was review, and you're a really smart kid, so you're gonna be good to go. This is not review. This is something different. You can change the directions because um, I made this worksheet up this morning. I pulled from a different worksheet, so I wouldn't have to copy all the graphs, and the directions were wrong, so we're changing it. Write a rule for the function. So there's a number of different answers you can come up with for these, but you'll kind of see what happens. So bring us back to trying to connect our learning to something else we've done. Remember when we graphed these parent functions and their transformations? Now what we're going to do is you're given the actual graph, you have to write what the equation or the rule would be. So I did not do this last year, but I've been frustrated for many years in people's inability to express graphs appropriately. We need to have more visuals. And that's really when I believe mathematics comes to life, is when you can see it. So we'll give this a shot. First of all, for number one, you should recognize that this comes from y equals the absolute value of x. There are three different transformations that take place for this one. What are they? Okay, so to the left 4, down 2, and then what else do we have? Vertical flip. So, you're going to have right 4, so x plus 4. You're going to have down 2, so minus 2, and then it's a vertical flip, so you got a minus in front of the function. What do you think? Can you do that? All right, let's do a bunch together. Second one. Sorry that my the picture didn't turn out very well. That's just the way it is. I don't know, but your copy turned out pretty good, right? It's the smart board. I don't know what's. Anyway, yeah, it's not very smart. So we have two different functions here. We could either have y equals x squared. Does anybody know a different one we have that looks very similar to that? X to the fourth. So I have not drawn the graph specific enough so that you know the difference between x squared or x to the fourth. So technically, you could give two types of answers that would fit this. I think most people would just pick to work with x squared. Do you see that? So I just want you to know that either one would technically fit, but we're just going to choose x squared. So what is our transformation here? We got what? Right 3 and down 1. So we've got y equals, we want to go right 3, we're going to go minus 3, and down 1 is going to be minus 1. That's it. How about number 3? That's a bird function, huh? Upside down? Bird function is y equals x to the 2/3. So we've got three things going on here. Left 3, up 3, and we've got the flip. So yeah, we've got y equals, we're going to need parentheses because we have that horizontal shift. So x plus 3 to the 2/3. And it is a vertical flip. And then it's also shifted up 3. Number 4, what's the parent function for that? Very good. It's a reciprocal function, y equals 1 over x. Like that. And how is this different than its parent function? 2 to the right. So it's just going to be y equals 1 over x minus 2. What do you think of that? Don't get that one? So normally the asymptotes are centered at 0, 0. You have one of y equals 0 and one of x equals 0, but that's all shifted over 2 units. And so therefore, since it's right 2, we've got an x minus 2. The minus 2 is on the inside. Inside. Two transformations for number 5. What's the parent function first? X to the third. What other one could you choose? X to the fifth. We'll choose x to the third. So what are my two transformations? Left 3. vertical flip. So if I have left 3, x plus 3, and then vertical flip, negative. How about number 6? What's the parent function? Root of x. Just one shift. What is it? Yeah, it's 4 to the left, so it's going to be y equals the square root of x plus 4. How's about number 7? Up 2, what else? Flip. Vertical flip, isn't it? So this is y equals 1 over x. Is there any horizontal thing going on? No. So we can just still have y equals 1 over x, but we have to make it negative. You can put the negative with the top, so like a -1, or you can put the negative with the bottom, or you can put the negative up front. Either way, it's the same situation. And then it's a vertical shift, as you said, up 2. We're going to do 3 more together. We're going to skip 8. You can do that on your own. We're going to look at 9. 9 is just a line, right? Y equals mx plus b. So what's m? Close. -2. Slope is -2. What's the y-intercept? Flip it over 2 more. How about 11? What's the parent function? Not 10, 11. What would the parent function be for 15? 1 over x squared, because they are both, if they're both going down or they're both going up, then it's got to be a squared or a fourth or something to an even power. If they're going in opposite directions, then it's an odd power. That's the way it works. So I've got 3 transformations going on here. What are they? Left 3, down 2, and a vertical flip. So left 3, so plus 3. Vertical flip, so negative could go up front or on the top or through the bottom. Put on the bottom would have to be a -x minus a 3. I just put it out front. And then down 2, so -2. We're going to do 12. I'd like you to see if you can do it on your own first, see if you can get it. 12 is kind of a tough one. All right, let's see what you got. I got 4 things going on here. What are they? Right 2, up 1, vertical flip, horizontal flip. Ooh, boy, a lot. Now, we haven't really talked about any of these having horizontal flips. And the fact is that horizontal flip is usually something that just comes out in the wash, especially when we're working with polynomials. And a lot of times horizontal flips can be the same as vertical flips. And we'll learn more about that in the next lesson when we're talking about odd and even functions. Well, with a square root function, you can't get rid of that negative on the inside. You got to make sure you have it there. So y equals the square root of x is what we're going to have. So we got the square root piece, and you said that it's a vertical flip, so I know I'm going to have a negative out front, and it's up 1, so I know I have a plus 1 on the end. The question is, what do I put in the middle? If it's a horizontal flip, is x going to be positive or negative? It's going to be a negative x. And then when you figure out what number to put there, again, this is always what I try to think about. What is the horizontal shift? 2 or negative 2? 2. Okay? So we have to make it so that if you plugged in 2, you would get 0, right? So is negative 2 minus 2 0, or is positive 2 minus 2 0? Positive 2. So 2 minus x. That way, like I said, a 2 minus 2 is 0, so it's a shifted 2 units to the right, and the negatives in front of the x. If you wanted to think about it this way, you could say, well, it's an x minus 2 because it shifted 2 to the right, and then you got to run a negative through it, and then it would be a 2 minus x. So, either way you think about it would be the same. Anybody get it? Get it right? Bullets only counts in horseshoes and hand grenades, right? So, but good job. Okay, that's a tricky one. So where was your mistake? On the inside here? Raise your hand if you put a negative 2 down. Okay, all right. Well, that's good. We all learned something new then today, right? Okay. Bree, she's excited. She wants her assignment. Tell you what, Bree, I'll give you an assignment. 2.5 worksheet. Finish off the worksheet I gave you, and section 2.5, page 194, numbers 1 through 12. Again, you're going to be they're going to start by asking you what these do. You have to describe them. So what is f of x minus 3? What does that do? Yeah, you just write 3. Yep, how about this one? Vertical flip. Yep. So make it short and simple and write what it does. Describe it, okay? That's good, okay? If it's vertical, it's over x. If it's horizontal, it's over y. You don't have to state. We know what you're talking about. All right, Ryan, we missed you. We actually had a cell phone picture of you going for a while there. And apparently we sent it to you because we're a technology friendly environment, right? That's oh boy.